Hello, today we are going to start our work in financial maths and look at compound interest. So compound interest is where we put money into an account and in the first year we're going to earn a particular amount of interest. So our final amount of money in an account at the end of year one is going to be what we started with plus that interest. At the end of year two, to find the amount of interest we're going to earn, we take all of the money that we had at the end of year one and we get interest on all of that. So over time, because we're adding that interest each year and taking the overall percentage, our amount of money increases faster and faster. In fact, it technically increases exponentially. So this is different to simple interest, where you just get the amount of interest you get in year one, and that same amount gets added at the end of each year. So your money doesn't really build up exponentially, it builds up linearly. You add in the same amount of interest at the end of each year. With compound interest, which is going to be our focus in the Leaving Cert, we are going to have an exponential growth because we are getting the amount of interest on what's in our account at the end of each time interval. And that amount of money is going to grow over time. So our amount of interest that we get each year is going to grow over time. Now the formula that we have for this is on page 30 in our log tables, and it's the final value we end up with is equal to the principal. This is technically called the principal for historical reasons. You can think of it as being the present value, the money you start out with, or the money you have at present, multiplied by 1 plus the interest rate for the particular time period we're working with. This is always written as a decimal. It is very important to not make the mistake of leaving this as a percentage or anything like that. Always convert to a decimal. To the power of, so the whole bracket to the power of the number of time intervals we are dealing with. So we're going to have a look at an example of that in just a second. Something that is going to be relevant in the long run, but is just kind of implicit in the background now, is that when we're dealing with investments, when we're dealing with final values, we are making our payments at the beginning of a time interval. So when we say we invest money for 5 years, we mean we invest it today, and after a full 5 years has passed, then we're going to take it out again. So we're not investing at the end of the first year. There's no reason you would expect that it would be any different, but it will become relevant later. So just have in the back of your minds, when we're dealing with our final value type situations, we're going to be making our investment today, in the present, and then we're thinking about complete time periods down the road. Now, let's get into an example. What is the total interest earned on €2,000 invested at 2% AER over 5 years? Now, there's a little bit of jargon going on here. And the main one to point out here is AER, and in the other question I've given you EAR. It does not matter what they tell you. If it's a financial maths question and they give you a percentage that's AER or EAR, it just means the yearly interest rate. So this means the interest rate in years. So I with a little subscript of Y on it. So anytime you see AER or EAR, the A in it you can think of as standing for annual. So annual equivalent rate is AER, and it just means the interest rate per year. And that's all it means. So if we see a percentage and we don't have any further context for it, it's going to mean the yearly interest rate. If they tell us that the interest rate is over a different time period, that's fine. We can look at that in the future. But for right now, if it doesn't give you any further context, the percentage in these questions will mean the interest rate over a year. So we have a formula that would be connected to interest over time. So if I see a question like this, I'm going to go to page 30 in my log tables, and I'm going to write down that formula. So I have, because I've recognized that this is the style of question that it is. It's a compound interest type question because I'm told about interest over time. That's basically always going to mean compound interest. But in this question, I need to do a little bit more thinking because I haven't been asked for the final value. I've been asked for the total interest earned. Well, what would the total interest earned be? Percentage interest. Well, the total euro interest, the total amount of extra money I've got, so the interest I earn over all of this time period in euro would be whatever my final value is minus whatever amount of money I started with. That's the extra money that I've got. So that would be my total interest. And then my percentage interest will be the interest I earned all over where I started with, multiplied by 100 over 1. So I've now told myself the story of what I have, of what I need to do. I've figured out what I need to find, and I've written down all of my relevant formula. So if I look here, I need to know the total interest that I earn in euro. And to do that, I need to know the final value, and I have a formula for the final value. So I've now got my game plan. I've taken the English of the question, I've written out what they've asked me to do in as mathematical language as I can, and I now know the steps I need to take. So if I see a compound interest question, write down this formula here from page 30 in the log tables, and then sometimes we'll have to do a little bit of interpretation, try and think through what does it mean to be getting my total percentage interest, because this is obviously not the interest percentage that they ask us in the question. This is the yearly interest rate, and we're asked for the total interest over 5 years. So we need to work it out this way. Now, let's put this into practice. So we have f is equal to 1 is equal to p on 1 plus I to the power of t, and there's a tool that we can use for keeping track of these type of questions, which is going to be very important in the long run. So we're going to draw it in just a second, but we have f is equal to p on 1 plus I. In this case, it's I yearly to the t yearly. It's important that these are going to be in years and in years, or in months or in months. They have to be over the same time period. And we're going to look at that in more detail in a little while. So our present value, or our principal, is 2,000 euro. P is equal to 2,000 euro. Always lay out the information you've got clearly in this, because they come as big blocky English questions and we need to translate them. So I yearly, percentage I yearly, is going to be 2%. Put that into your calculator as 2 over 100. It's important to do this because they could have given you 0.2% and it would be very easy to make a mistake and just put down 0.2 for a decimal. So always write down what they give you divided by 100, and we get 0.02. And now do we have all our information? And t yearly is just 5 years. So we've got all of our information now for finding our final value. So we've got 2,000 on 1 plus 0.02 to the power of 5. When we put that into our calculator, we get 2208.1616. And yeah, I should draw this in. So an important tool for figuring out these types of questions that will be extremely important later, I'm going to just draw in here. Now, each of these bars is the end of a time period. So this is time period 0. So this is our present, or it would be the final value 0. This would be our final value at the end of year 1. So if we got the interest added on at the end of year 1, and then we'd have the compounding interest after year 2, year 3, year 4, we'd have the final value after 4 years have completed, and this would be the final value after 5 years have completed. They can give you questions where you take out money after several years or make lots of changes. So writing in these little dashes and keeping track of what year you're in and what money you'd have up until that point, what changes you make, this is going to be extremely important when we get into more advanced questions. So drawing in these pictures anytime we can to start getting us used to it is going to be important. So it's a way of keeping track of what money we would have at different periods of time, at different points in time. So this would be the end of year 1, and this would be the end of year 2. So we now have this F5, the money at the end of year 5. So this is our final value. So our euro interest is going to be our final minus our beginning. So it's going to be 2208.16 minus our starting value was 2000. So we earn 208 euro and 16 cents over 5 years. And then our percentage is going to be our percentage is going to be out of where we started, just like our percentage always is. So this is the percentage of the total, and I should have total written in here as well, is going to be euro total all over principal by 100 over 1. Ends up being 208.16 all over 2000 by 100 over 1. Ends up being equal to 0.10408. And you will see that I have gone to a significant number of decimal places. That's going to be a recurring theme here. You're going to go to a lot more decimal places with your interest rates than you ordinarily would. So that ends up being 10.408%. Now, an account offers an EAR of 0.6%. What is the monthly interest rate? The key thing here is to recognize that the final value, if we had an interest rate that was annually, like we were given here, so this is I yearly, because it's an EAR, the A tells us it's annual, the final value must end up being the same in both cases. So if I start out and use my formula, 1 plus I monthly to the power of, well, 12 months is a year, must be the same as 1 plus I yearly to the power of 1 year. This must be the same. If I have an interest rate over 12 months, that's a monthly interest rate, it must give me the same value as a yearly interest rate over 1 year. Sensible enough. So now I can sub in what I know. The p's don't matter. I can divide them out and I end up with 1 plus I monthly, which is what I'm looking for, to the power of 12 is equal to 1 plus, I need to turn that into a percentage, so give me a moment. So I have my I yearly all over 100 to turn it into a decimal. You can see how that could have tricked me. I could have put in 0.6 for my interest rate. Now I want to find out what I monthly is. I have it to the power of 12. I can take the 12th root of both sides. So just a button on our calculators. And we get 1 plus I monthly is equal to 1.0004983. And rearranging then, so subtract 1 from both sides to get I monthly by itself, and we get the interest rate, percentage interest per month, sorry, not percentage, our interest rate per month would be 0.0004983. Turning that into a percentage multiplied by 100 is equal to approximately 0.05%. So the key thing here is to recognize if they ask you ever to change from one type of interest rate to another, this case yearly to monthly, but it could have been quarterly. We could have been asked for the quarterly equivalent rate. And in that case, it would be a quarter of a year. We would have had the interest rate per quarter to the power of 4 would equal to the yearly interest rate to the power of 1. So over the same overall time period, the final values must be the same. And this is a fairly common question where we have to change between our different interest rates.